Welcome to day 11, Polymorphism. Today we will explore the fascinating world of compile time and runtime polymorphism in object-oriented programming. So, what exactly is polymorphism? The term comes from Greek meaning many shapes. In programming, it refers to the ability of a method or function to behave differently based on the type of object calling it. This concept is incredibly powerful because it simplifies code, making it more flexible. One interface can be used for different data types, allowing for a cleaner and more reusable code structure. There are two main types of polymorphism: compile time polymorphism, runtime polymorphism. Compile time polymorphism, also known as static polymorphism, which occurs at compile time. This is achieved through method overloading and operator overloading. Runtime polymorphism, also called dynamic polymorphism, which occurs during runtime and is achieved via method overriding. Let's dive into compile time polymorphism. Method overloading is a key concept here. This occurs when multiple methods have the same name but differ in their parameters, either in type or number. For example, in this class printer, we have two print methods, one for integers and one for doubles. The compiler decides which method to use based on the argument type at the compile time. Now let's talk about runtime polymorphism. This happens when a method in a base class is overridden by a method in a derived class. This allows the method to behave differently depending on the actual object type at runtime. For example, we have a base class animal with a virtual sound method. The derived class dog overrides the sound method to output bark. When we create an instance of dog, the sound method dynamically calls the method in the dog class, not the base animal class. Function overloading is a perfect example of compile time polymorphism. It occurs when multiple functions share the same name but have different parameter types or numbers. The compiler will determine which function to call based on the parameters passed to it. Method overriding is a feature of runtime polymorphism. It allows a method in a derived class to replace or override the behavior of the base class method. The base class method must be marked with a virtual keyword, and the derived class must use the override keyword. Virtual methods enable runtime polymorphism by ensuring that the method call corresponds to the actual object type, not the reference type. The decision of which method to call is made at runtime. This is called dynamic dispatch. Let's practice what we have learned. Create a base class shape with a virtual draw method and override this method in derived classes such as circle and rectangle. When you call the draw method on objects of these derived classes, we expect to see the appropriate output for each shape. Polymorphism brings several advantages. It enhances flexibility, allowing you to create objects of different types as objects of a common base class. It also promotes extensibility. New classes can be added without modifying existing code. Lastly, polymorphism improves code reusability, allowing the same method to be used across different classes and behaviors. To summarize, polymorphism allows one method to operate in multiple ways, simplifying and enhancing code flexibility. We have covered two main types of polymorphism: compile time, which is achieved through method overloading, and runtime, which is achieved through method overriding. The methods include improved the benefits include improved flexibility, code reusability, and extensibility. Next time we will explore another important concept in OOP: composition versus inheritance. We will learn when to use composition over inheritance to create more flexible and maintainable code. See you in the next session.